In this video series, we are going to study science chapters of grade 10 SEE exams. Now we are going to study physics chapter light. So in this series, we have been solving questions of your set book, one of your set books. But in this part, we are going to discuss important topics of the chapter like construction of ray diagram. This is part 2 of the chapter. Yes, in part 1, we did construction of ray diagram by convex lens. Yes, so this is part 2. So we'll be doing important topics of the chapter. These topics are very important for examination point of view. Okay, you'll get the question from this part. Ray diagram is very important. So you see, we are going to make ray diagrams, construct ray diagrams for two positions by concave lens. Okay, two positions are object kept between infinity and focus, anywhere in between infinity and focus. And second one is when the object is kept at infinity, right? So when the object is in between infinity and the focus, then the image will be formed between focus and optical center. Yes, in front of focus, right? And when the object is at infinity, image will be formed at focus, right? The rules, we will see the rules over here. Now nature of the image will be virtual and erect. Concave lens always virtual and erect. When the image is virtual, it is always erect, standing upright, and size is diminished in case of concave lens. Yes, the size of the image is smaller, okay, in concave lens, smaller than the object. So we will see this one. This is principal axis. Yes, make 5 positions on principal axis, and this position should be equidistant from each other. 1, 2, 3, 4, 5. Yes, this one. This is F position. This is 2F. This is F position. This is 2F position. And the middle one is lens position. Do not make lens very big. Okay, do not make it very high or low. Okay, and a little bit more than 2 lines in your notebook if you are using notebook. This is concave lens, thick, thin in the middle and thick on the edges. This is lens, concave lens. Okay, now rules. Let's see the rules. When the light rays are parallel to the principal axis, then after striking on the lens, after refraction, the ray diverges away from the focus. Okay, it goes away. Diverging ray. Yes, and it appears to diverge from the focus. So if you produce it backward, it appears to come from focus. Okay, so this one, and the ray which is passing through the focus will pass out undeviated without bending. So you have to remember these two rules. The light ray parallel to the principal axis will diverge away after refraction. It appears to diverge away from the focus. Yes, it appears to come from focus, right? And the light ray which is passing through the optical center will pass out undeviated without bending. So you have to remember these two. If you consider these two lines, then your ray diagram, you have to make ray diagram by using these two lines. Okay, representative rays of light. Okay, numerous light rays will be coming out from the object, but you have to take only two types. Okay, parallel to the principal axis and diverging away, and another ray of light is passing through optical center. Okay, which passes out undeviated without bending. So this is the rule. Now you have to be careful with this in case of concave lens, because the light rays diverge away after striking on the lens after refraction, diverging away. Yes, now we'll see the ray diagram here, actual ray diagram. You have to keep object in between infinity and the focus. The first one, the first ray diagram, this one, this is principal axis. Take 5 positions: lens position, focus 2F, focus 2F. All these 5 points should be equidistant from each other. This is F position, this is 2F, this is F position, this is 2F, and this is lens position. This is lens. Okay, concave lens. Now you have to consider an object standing in between infinity and focus, anywhere in between infinity and the focus. Infinity is far distance, this is far away distance, and let the object be standing at this point. Okay, A and B. Alright, now you have to consider two light rays coming out from the object at the top of the object from this point. So one ray is parallel to the principal axis and diverges away after refraction. Okay, and it appears to diverge away from the focus, this one. If you produce it backward, it will be crossing through the focus. That is why it appears to diverge away from the focus, right? And another light ray passing through the optical center, this one. Now you see, you find these two lines cutting each other at this point. Okay, in between focus and the optical center. This is optical center. Yes, and this is smaller in size. Now A dash, B dash, right? A dash and B dash. So image will be formed in between focus and the optical center over here. Now you see, you have to get an image in this one. So image will be formed when two rays of light will crush each other at the point where two light rays crush each other, right? So if we try to get image in this side in real case, then it is not possible because light rays are diverging away. So if you produce this backward, then they will meet at one point. Okay, at that point image will be formed. So in order to form image, you have to produce it backward. Yes, and you will find that these two light rays, refracted rays, will be cutting each other at this point, right? So image will be formed at this point, A dash, B dash. Now you can see nature of the image is virtual because it is on the same side of the object, virtual. And if it is virtual, then it is always upright, standing up, upright. Okay, and it is diminished, smaller in size, diminished. Okay, and position is in between F and O, focus and optical center. Yes, this is the ray construction of ray diagram for first position, object between infinity and the focus. Now we'll see next ray diagram for position infinity, object at infinity. This is principal focus. Okay, take 5 positions over here, 1 2 3 4 5. This is F position, this is 2F, this is F, this is 2F. Then this middle one is lens position, concave lens. Okay, concave lens. And you have to consider two light rays coming from infinity because this is infinity distance. Yes, infinity distance. So light ray parallel to the principal axis, light ray parallel to the principal axis. After refraction diverges away, okay, and you have to produce it backward, these two light rays appear to meet at the focus. They appear to cut each other at focus point, right? So image will be formed at the focus because these two light rays are crushing each other at the focus. Okay, whenever you draw light rays, you must show arrows because light rays have definite direction to move. Okay, so the image will be formed at focus and it is highly diminished. You can see it is at a point, right? So virtual, upright. When it is virtual, it is always upright, and in case of concave lens, the image is diminished and it is highly diminished. In this case, it is highly diminished. Okay, very small, highly diminished, and the position is at F. Image will be formed at focus. Okay, so this is the construction of ray diagram by concave lens. So the lines are refracted rays are appear to diverge away from focus. Appear, okay, you have to use the word appear because these are not cutting each other in actual manner. You are producing them backward, then only they crush each other. That is why we use the word appear. Okay, appear to crush each other at this point. It appears to, you know, meet the next line, the this light ray at this point. So this is the construction of ray diagram by concave lens.